Hi, everybody. Welcome after the break. Hope everybody had a little bit of caffeine and is raring to go. We got a lot to cover, so without further ado, I'm just going to ask Justin Taylor, Vice President of Artificial Intelligence from Lockheed Martin, to join me on stage.
Thanks, Chris.
Yeah, welcome, Justin. Glad you're here.
Yeah, happy to be here. Thanks for the opportunity.
So, VP of Artificial Intelligence. Your whole career has been at Lockheed, right? So, how did you get there?
Yeah, that's right. So I currently serve as the Vice President of Artificial Intelligence and Machine Learning at Lockheed Martin. I had the privilege of starting my career at Lockheed over 2 decades ago. It goes very fast. I started as a software engineer, and I actually came into the defense industry already with a passion to bring the latest and greatest from commercial, so hardware, software, and development techniques, to the Department of Defense. That was a passion I had from the get-go, and I've had a really blessed and privileged career to be able to actually make some impact in that regard. Started out in doing flight simulation and a lot of experimentation to see what mission capabilities would work best, and then that progressed from being in the lab to then moving to airplanes for flight test, and then that progressed into being able to really pave the way for how we bring advanced technology at that time into all of our aircraft, because I spent 21 years at Lockheed Martin Aeronautics and got to have a breadth of experience on mission systems capabilities, including artificial intelligence, advanced software techniques. And then for the past year and a half, I've been at corporate serving as the Vice President of AI. So what does that mean? It means I'm responsible for driving artificial intelligence and machine learning as an engineering discipline, a new engineering discipline across the enterprise. So there's a lot that goes into that. But I also have the opportunity to serve as the lead for the LAIC, the LAIC, the Lockheed Martin Artificial Intelligence Center. So what the LAIC is our corporate center that's focused on enabling the entire Lockheed enterprise to accelerate the application of artificial intelligence and do it at scale and speed the transition of capabilities to our end users, which is what we're passionate about, to lower the barrier to entry to wield AI.
Excellent. Sounds like it's been quite a career.
It's been a lot of fun.
Great. So let's talk about drones. There have been a number of articles recently over the past year that have noted that drones are sort of changing the nature of battle, right? Mm-hmm. Aerial reconnaissance drones becoming the new face of military power. So what can drones do to help support troops in theater?
So what I like to focus on is how drones and that type of autonomy technology can really make our brave men and women safer by keeping them further out of harm's way. And unmanned platforms is not new. We've had unmanned platforms in every domain. In the past years, we've had, of course, remotely piloted aircraft before. And so what's new technologically that's making those folks that much safer and being able to prosecute missions from further back is new breakthroughs in technology. And so from an artificial intelligence machine learning perspective, you can think about it just looking at each individual human operator. How can we have them make the most out of what's in front of them, to squeeze the most out of the resources and limited assets that they have? And so on platform, on the drones and UAVs in this example, you can think about each of the individual sensors that they have. How can AI help them to be able to process that? We call that cognitive sensing. You can think about that across any sensor modality, so radio frequency or applying AI, for example, to computer vision and EO and IR, visible spectrum, automatic target recognition. So there's a breadth of applicability of bringing AI techniques to each of those sensor modalities, and it allows them to then make the most out of the limited resources that you have on each platform. One of the big challenges when we think about bringing commercial tech to the edge is the fact that in a small UAV and drone, for example, you're very limited in SWaP, size, weight, and power. And so being able to make the most out of those hardware resources is really key. And so you can think about then how can AI help you with each of those individual sensor modalities, but then you really get impact when you're able to have AI capabilities enable those operators to blur the lines across those sensor modalities. And that's just making each human operator be able to do the most out of a single asset, but then the bigger impacts are multiple assets. And so you can think about homogeneous swarms, as it were, of the same type of UAV and drones. But even more exciting is when you think about heterogeneity and distinctly different types of platforms being able to work together. And even beyond just the air layer, thinking about across space, land, air, surface, subsurface, being able to have those platforms work together in a concerted way to be able to make those brave men and women safer, to be able to see further and see further out.
Oh, that's great to hear. I mean, one of the themes here obviously today is edge, right? And the edge is not just going to be in the air on a drone, right? It's any place you've got a small form factor and limited swap, as you mentioned. So that's great. So because there are limits, right? Maybe you could walk us through some of the technologies needed to make a drone effective in modern warfare.
Yeah. So make drones effective in modern warfare. The way I like to frame that is to think big picture concepts and big picture visions. So what I like to go to for this topic, an example, is a term that has come out of the Department of Defense, in particular DARPA, the Defense Advanced Research Projects Agency. And that term and concept and vision is called mosaic warfare. And so it's about being able to make the most out of the assets that are in front of you. So what does mosaic mean? It's an analogy that's contrasting, say, jigsaw puzzle pieces. Envision that you have a table and all your assets are represented by the jigsaw puzzle pieces. Well, those puzzle pieces only go together in one way, one fixed way, and that's what you have in front of you, and very limited in what you can do. Whereas a mosaic, I think from an art perspective, is comprised of tiles. And so you can envision that putting those tiles together in whatever way you need to give you flexibility based on your current mission. So that's the mosaic warfare concept and what the analogy represents. And so comparing fixed interface jigsaw puzzle pieces to mosaic tiles is pointing to fixed capabilities, limited interfaces and interoperability compared to ad hoc, being able to take any asset that you have available and being able to piece it together in a different way. So it's about flexibility for the warfighter to make the most out of the resources and assets that they have in front of them. So if you think about that as the big picture vision, we've been a long way away from being able to realize that. And as a technologist, what I care about is what are the core foundational technologies that are necessary to make that picture a reality. And that's broad. And across the DoD, R&D domain space, we're making progress in each of those swim lanes and avenues. You can think about it in terms of rapid interoperability. So interface adaptation at the edge, which has rippling impacts all the way back to system engineering. But you can also think about the foundational infrastructure, both software and hardware, for both your development environment all the way through to actually getting on platform. And so some key foundational breakthroughs on that is what it takes to take Kubernetes, for example, and things like Red Hat, Microshift, and now Device Edge, being able to have that enable us to have these software payloads, these software capabilities, be able to transit all the way from the developer's desk through to the platforms. And so last month we had the opportunity to fly and be the first to get to fly Red Hat Microshift Device Edge on some small UAVs. You heard Chris this morning introduce a really cool video that shows what that looks like.
I've seen the video, it's great.
Yeah, it's a lot of fun.
Yeah.
But that's just the beginning. So in that case, what we did is show the core foundational technology of being able to have new, what we call AI, software payloads, be able to actually be shifted and swapped out in flight. And so remember, it's about making the most out of the tools that are in front of you. And so when you have limited compute, even on a single asset, being able to shift in mission from, say, having that particular UAV focused on RF sensing versus now needing to shift to do computer vision. That was the demo that we did last month. But that's just the beginning, because then it's expanding to multiple homogeneous UAVs and then multiple heterogeneous platforms, manned and unmanned, across multiple domains. And so there's a lot of foundational technology that's necessary to make that possible. It's been really exciting to see how quickly we can provide capability in the hands of the end user when we have these individual breakthroughs.
So one of the things we talked about earlier was a pipeline capability for being able to develop that software and those AI models sort of back at a central location, but then being able to propagate them through various layers as you get further and further out to the edge, right?
That's right.
And being able to run on top of a common platform so that all of that development that's done centrally will be effective and be usable no matter where you go in the platform. So can you give us a little bit about what tools you use, what techniques you use?
Yeah, and so having entered the industry as a software developer, I've always been passionate about what does it look like to make it real for those engineers. So think about those engineers coming out of college. How can you make them immediately buy into the mission and be lifelong employees to bring the latest and greatest technology to the warfighter. It's by connecting them to that mission from the get-go. And so that is totally different today than it was 20 plus years ago when I entered the workforce, because now you can envision an actual development pipeline all the way from their desk, being a software developer or AI practitioner, all the way through to the platform itself, actually doing over-the-air updates to the platforms to get them ready for their next mission, and even more provocative, thinking even further than that, actually having platforms shift roles in mission. And so what technology do we need to make that possible? A lot. And so I like to think about it from an AI perspective as what do we need for an AI pipeline, all the way from developer's desk to the platform, the physical platform itself. And so what we've had to do to be able to make that happen, both make it possible, but then also make it available at scale to a large workforce, is what we call an AI factory. And so most folks in organizations are familiar on the software development side with the concept of a software factory, which includes curating the right tools and development tool sets and software tool suite to enable software development, DevSecOps, all the way to testing and deployment. And so what we've done internally as an example and as a best practice for AI organizations is to stand up an AI factory, which is an analog complement to our software factory that's curating that best-of-breed technology, which is updating so fast. When you think about the free and open source software world, think about just what Red Hat does. Being able to keep pace there, we've got to curate that tool suite quickly and be able to understand all the missions that we have in front of us. What are the unique needs that we need to meet? And so our AI factory approach then is recognizing that the data and the data pipeline and data provenance, data to train our AI machine learning models, all the way to what happens once you hand it to the end user and you're updating those in field and in mission. There's a lot of tools that are necessary to make that possible and make it easy for folks. And so we've been investing in what that looks like to then have that propagate at scale from an efficiency perspective. And so back to that big picture pipeline from developer's desk to the end user, being able to stand on common environments and have our developers develop in a Kubernetes environment from their desk, and then have that capability, that mission capability transit through all those many steps to result in that actual pod being loaded up to a platform, in this case the drones. We're doing it in mission swaps, is incredible. It's what I would have dreamed of doing when I started in the workforce, and it's just so cool that we're making that available now to our important talent to enable the warfighter.
Yeah, it really is amazing how far along FOSS has come and provided capabilities like this within the DoD that we wouldn't have seen 20, 25 years ago, right, as far back in my career. So since you are doing all of these really cool and interesting things within the DoD, did you run into any barriers that you had to overcome when you were implementing these capabilities?
No, it was all easy.
It was all easy. Well, that's great. I'm glad to hear it.
Yeah, did we have any barriers? For sure. There's many barriers that we have overcome, but maybe even more important are the barriers that are still in front of us. So let me highlight a couple. I'll start with free and open source software, or FOSS, and then I'll talk about trust. So free and open source software, which is applicable to talk about at a Red Hat conference,
absolutely,
is obviously critical for any advanced technology, especially when we're trying to bring the best of breed from commercial and apply it to the defense domain space. So that's been a serious challenge over certainly my career. It's been incredible to see the progress that we've made, but we have a long way in front of us as well. And so why do I start with free and open source software as a key barrier? It's because wearing an AI hat, it's a completely different ballgame. You can think about, it's obvious that we need free and open source software for traditional software development. It's an order of magnitude more FOSS that is needed for AI and machine learning. And so what we've seen from a DoD perspective is a cultural pivot. So what barriers did we overcome? I think it's safe to assert that the DoD has overcome the cultural barriers.
For the use of open source
For the
software,
use of
yeah,
free and open source software. But what's in front of us is still how to make it that much more efficient and combining forces. So I mentioned that free and open source software and the commercial development environment goes very fast, especially with artificial intelligence. And so while we're over the cultural barriers, now we have the challenge of how do we embrace that and get the efficiency such that we can embrace the latest and greatest at that rapid tempo. So that's one piece. We've also seen that each of the individual DoD services and down to the individual customer offices have initiatives in place to make it easier and to some degree faster to work through those approvals and certifications. But when our big picture vision is blurring lines across domains, space, air, land, sea, surface, subsurface, that's different offices and different programs and different services. And so being able to get lift from one to the other is really key. The AI breakthroughs that we have for one mission, although it represents a specific implementation, the technique breakthroughs are applicable to other domains and other sensor phenomenologies and sensor modalities. And so the better that we can get efficient at crossing lines between given customers and bringing those capabilities, which requires that underlying free and open source software base, the more efficient we can get at that, the better. So that's one piece is FOSS. Other barriers include whenever we're talking about artificial intelligence and machine learning, it's a journey of trust. It's a journey of trust with each individual user for that program, for that mission. And that's the way it's got to be. And that's something we're used to for autonomy broadly, right? And so what we recognize is how important it is to have the end user and the end user community be part of that development process up front so they can understand what the AI is doing.
So you're really talking about the interface between the human and the machine, right? And being able to trust that and then having the humans provide input into the process to begin with so that trust gets built.
And how does the human have trust? They understand what the machine is doing. And they can ask the engineering organization and staff why decisions were made. And the more that they can get insight into that, the better. So in AI, we talk about verification, validation, and explainability. And so those are natural barriers that are always going to be there. And so the way that we mitigate that is to have those end users part of the development process from the get-go. But then as we think about how do we get lift from one program and one service from one domain to another, it's by sharing those success stories and sharing those experiences so that we can get to the point where we're not always starting from ground zero with each individual user to develop trust, but say the Air Force can look at the Navy and have an understanding of how their AI breakthrough worked for them, and they can kind of start from that position so they're further down the field for where they're going to go for their mission.
Yeah, I think that's great. That makes sense. The more trust that we can build and the more that we can actually reuse those capabilities is just going to bring everybody further along.
Exactly.
So you mentioned that you might be using an AI package for a specific mission, but the base capability of that is actually something that's more broadly applicable.
That's right.
And we've been talking about drone use within the DoD specifically, but I was wondering if there are any civilian applications that this technology might also apply to.
Yeah, there are, and it can be obvious to folks that AI and machine learning breakthroughs in one domain will be applicable to another. What we've been excited about is to even get outside the defense domain and see how we could help with other existential challenges and threats that we have. And so part of the vision and mission that we have for my organization is to apply artificial intelligence to enable a safe and secure world. And so security is straightforward for the defense side, for national security, for deterrence, but climate challenges are an existential problem for us on the safety side. And so we have been able to work a program that's focused on wildfire fighting. So we picked that one because, one, we had a hunch that AI techniques would be able to have quick breakthroughs on addressing the challenge of wildfires, but we also picked it because it's a worldwide challenge that I suspect everybody in the room has either experienced or has family that has experienced the threat of wildfires damaging property. Huge investments by the US government, $4 billion last year to address the damages of wildfires. So that's a real problem. And the technology that our brave men and women have been using to date is fairly dated. The algorithms are from the 70s, actually, to be able to detect the perimeter and attempt to figure out how to marshal resources to suppress wildfires. And so what we've been able to do is to show in less than a year's time how quickly we can apply AI, in particular machine learning techniques, to first detect that there is a wildfire, and then to do what we refer to as perimeter generation. So generate the actual perimeter so that those commanders that are trying to decide how to prosecute the fire, as it were, are able to do so in an efficient way. But then we've also been able to apply artificial intelligence already to then predict the firefront behavior, the expansion of that fire. Because time is of the essence here. Like the quicker that you can get that result, if you can get it an order of magnitude faster rather than days to hours and rather from hours to minutes, then you're that much more efficient, obviously, on taking advantage of what you can do to suppress the fire. So we've shown how AI can help us there already with perimeter generation and firefront behavior prediction. The next step is more on the reinforcement learning side to then plan. So plan for those resources. That's the mission management part of this. And the wildfire problem has incredible analogies to our defense domain space.
I was thinking that myself, right? You've got a theater of operation, you've got to marshal resources, you've got to deploy personnel, all in, for an objective, right? So yeah.
That's right, and you have folks that are having different roles, that have communication challenges for how to communicate that, how to do that digitally so that they're working from the same sheet of music, being able to process all that data, whether it's satellite data or drones that are now being dispersed to get new looks at the fire live in real time, and to be able to process all that data is a significant challenge. And so there are analogs across the board for where we've been able to bring our insights for defense mission management and apply that insight and mission expertise to wildland fire management. It's been a lot of fun. It's been an exciting program. More to come on that as we continue to do flight tests next year and get these AI capabilities up in the air to protect those men and women.
It's great, yeah. I mean, all we can do to protect our troops of any flavor, right?
That's right.
So since we kind of touched back on the defense side of things, I'm curious what you think the battlefield is going to look like in 5 years with respect to drones.
Yeah, it's always risky business to do predictions, right? Insert election joke here.
Right.
Day after elections. So yeah, so it's a risky business to try to predict the future, and especially in advanced technology, and of course I would assert especially in artificial intelligence, which is moving so fast. But what I would say is that we like to frame the challenge in front of us for that big picture vision for Department of Defense. You heard about JADC2, Joint All-Domain Command and Control, from the Air Force gentleman this morning. That's a big picture vision with a lot of complexity. And the Department of Defense has been clear that artificial intelligence and machine learning is a key enabling technology to be able to realize that vision. And they break it up into sensing, making sense, and act. And I would highlight that we've made the most progress on the capabilities that we have transitioned already today across multiple domains, and being able to sense, process all that data, and then make sense of it to enable those human operators to be able to operate at that much higher level of performance. And then what's still in front of us is on the act piece, which we like to break up in terms of automating their current workflows, making them that much more valuable and enabled, as well as moving forward for course of action generation, et cetera. AI is broad for that. So what's going to be the battlefield in 5 years? I think for individual operators in each individual domain, they're going to feel a significant impact on how much more efficient they can be to do their job. They're going to be able to automate that sensing pipeline, be able to make sense much faster, and they're going to experience that they have much more, have the human do what they do best and the machines do what they do best to enable a greater purview. So I think individual operators are going to feel that. I think what we'll see in terms of what does the battle space look like in 5 years is more the cross-domain piece. So just like we're blurring lines for mission management for wildfire fighting, you're going to see the same cross-domain for the defense side.
Great. Well, I'll make sure to hold you to those predictions in 5 years.
Thanks for that.
Someone's recorded this, right? So with the minute that we got left, you got any closing thoughts?
Well, I appreciate the opportunity to share today. I think that our experiences at Lockheed are similar to any large organization that is seeking to lower that barrier to entry to enable a broader workforce to wield AI for the greater good. For us, it's exciting to see how we're able to take advantage of these advanced technologies, bringing the best of the commercial world and applying it to the defense domain, to our customers that have the hardest challenges in front of them to enable a safe and secure world. And so if folks have questions for how we're structured, I'm happy to be able to meet with you after. And I really appreciate the opportunity to be here today.
Well, we really appreciate you being here. Thank you very much.
Thank you. Thanks, Chris. Yep. Appreciate it.